Let's see how she rolls. Nice. Hey. Okay. Let's get this stuff done. Done. Oh, look at that. There you are. Okay, so you're saying you're chapter 5. Yes, this reference sheet. She said she's giving you the identities. Okay. Okay, but she's giving you the identities, right? She's giving you like sine squared. Oops. Sine squared plus cos squared equals 1, right? She's giving you, I don't know, was there any other identities you actually used? I think there was. Under fundamentals. There's a lot of identities. The whole thing on the right hand side is all identities. Except for the law of sines and law of cosines. Something tells me that I'm pretty sure she's giving you this identity. Okay, what else could possibly be on there? You said from chapter 5, right? Chapter 5 and 6? Let me just quickly check. Trig ratios, respect angles, yeah. Still trig identities. Tan is sine over cos. Like the reciprocal identities, I'm guessing. Mm-hmm. Sine law, cosine law. This is the test you used last year? Alright. Let us take a look. Mm-hmm. Okay. Really? She's going to use angled rectangles? You see this? You see this? This angled rectangle? Couldn't you use just a flat rectangle in 2D space? You had to angle it? Okay. Well, I don't see anything about just knowing the trig identities or trig angles, except for in 7. Finish the proof. It's using identities. Very simple, finish the proof. Slap stuffs out of the textbook. This one, fine. Given that the angle lies in which quadrant, blah, 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 determine the rest of the angles. That's finally a good answer. One of the questions from your assignment didn't tell you which quadrant, so it had like 2 possibilities. Okay. Well, first things first. Unit review in the text. Well, here's the thing. I'll tell you what you actually have to memorize, the rest you can figure out. Let me just find the chapter review. Ever. Let's just talk about what you need to know first. Okay. First things first, you need to know the regular trig identities, all 6. The trig ratios. So you need to understand what about the triangle. So this is like the top left-hand corner of our reference sheet. X, Y, R, and theta. Okay? The things you have to memorize is literally those 6 things about sine, cosine, tangent, and you'll go from there. For starters, once you know the first three, you know the second three because you just flip them, right? So sine is just y over r. Okay, cosine, well, it's the other one, x over r. Tangent is just y over x. Needing to know the opposite or reciprocal ones, a good rule of thumb or thing to change is to say sine starts with an s, so cosecant is the 1 over sine. If you change the letter, you know which one it is. This one, so, and all you have to do is flip, so r over y. Cosine starts with a c, so secant. And you just flip, r over x. Tangent, cotangent. You just flip, x over y. So, memorizing the first 6 things, pretty straightforward. You just have to know sine, cosine, and tangent. Then the other ones are just the flips. You only need to know that cotan is 1 over tan. Cosecant is 1 over sine. And secant is 1 over cosine. This is like half of the first part you actually need to memorize. Are you good with this so far for understanding that this is just stuff you need to memorize? Those are reciprocal identity. Yep, cotan is just 1 over tan. Okay. So these are just the first things you have to just standard memorize, okay? The triangle is a one piece. Knowing the y and the r and the x and the r, all that stuff for each of them. That's just straight up, you have to memorize those. No other real way around it. Okay? Second part, you have to memorize 2 triangles. So if we have this table of all these real values, okay? The real values of sine, cos, and tan, all those things. Yeah, that's what we're getting into, is special triangles. You just need to memorize 2 triangles. The first triangle you have to know is a very simple one where it has a 45-degree angle. Okay? The side lengths of the triangle is 1, 1, root 2. Okay? The second triangle again, this is just the things you have to memorize. The second triangle looks slightly different. It has a 30-degree angle and a 60-degree angle. And the side lengths are 1, 2, and root 3. Okay? 2 triangles, right up. That's it. You have to just memorize those 2 triangles. Okay? Write them down 10 times if you have to. Just remember them. They're pretty straightforward and easy to remember. 1, 2 in root 3 and 1, 1 in root 2. Okay. Because we memorized all of these, we now know all the special angles. For example, what is sine of 45 degrees? Well, sine of 45 degrees, well, here's our triangle. That's 45 degrees. Sine is y over r. So here's our y, which is 1, and our root 2. So sine 45 degrees is 1 over the square root of 2. Then you have to rationalize like we did in the past. So you multiply by root 2 over root 2. So we get root 2 over 2. Okay? Cosine of 45 degrees. Because most classes, and I'm going to say most classes, do not like you leaving it as 1 over root 2. They do not like the radical in the denominator. They want you to rationalize your answer every time. So to rationalize it, you still had to multiply by root 2 over. Then cosine. And, you know, all of them. What's given this? What is secant of 60 degrees? Right? All you have to do is understand the triangles. Okay? Secant is 1 over cosine. Cosine of 60 degrees would be, well, 1 over 2. So secant of 60 degrees would be 1 over 2, so 2. Okay, you're back. So to fill out the remaining values, or any value that you want, you just use these 2 triangles. Don't worry about it. We can just continue. So, like I was saying before, these 2 special triangles gives us all our angles. It fills out our chart for us, and then some. I just didn't even fill them all out on this chart. We could go cosine of 60 degrees. We could do cosecant of 30 degrees or anything. That's what those 2 triangles are for. So you know your SOHCAHTOA. You know how to memorize these. Yes. So you need to just memorize these two triangles, and then you can fill out any of those special angles. So if I asked you what, let's say, what is tan of 30 degrees, you can tell me just by looking at this triangle. So what is tan of 30 degrees? Tan. What's tan of 30 degrees? Come on, you can do it. Tan, bud. What is tan? Tan is y over x, right? Knowing our triangle, here's our y, here's our x. 1 over root 3. Then you need to rationalize it. So root 3 over 3. A good way for you to like double check that you understand how to use these triangles is to actually try and fill out this chart. Do it yourself. If you can fill out the chart yourself the same way as it's written on here, then you're golden. Okay, what is tan of 45 degrees? Mm-hmm. 1 over 1, so 1. What is secant of 45 degrees? No, secant. Again, you have to go back to these every single time. I've given you these to memorize for a reason. Tell me what is secant of 45 degrees? Let's see it. So what is secant of 45 degrees? Secant, yes, is 1 over cos. So this would just be root 2. What is tan of 60 degrees? Let's do tan of 60. Nope. You just have to understand that 60 degrees is up in this corner. So do the triangle as if this is the corner up at the top right. Okay? Another way to look at it is, remember that on this sheet, we had the opposite and the hypotenuse and the adjacent words written in here. No. We're going to go from this side, which is 60 degrees. Tangent, if you remember, is opposite over adjacent. If I redraw this triangle to be 30 degrees, 60 degrees here and 30 degrees here, this is still 2, but this is 1 and this is root 3. So if I redraw the triangle, which you don't need to do, you can redraw it so that 60 degrees is down here. Okay? Then the side lengths are still going to be the same in their corresponding places. The hypotenuse is still 2. The short side between 60 and the right triangle, the right angle, is going to be 1. And then the long side will be root 3. Tangent, like we said before, like in your SOHCAHTOA, is opposite over adjacent. So tan of 60 degrees yes, it'll be the root 3. Okay. What is sine of 30 degrees? Yep, sine of 30 degrees is 1/2. So do you see how to get that? Using these two triangles and using these things that we memorized, So there's a clear thing that you have to memorize. This page, it seems likely, and these two triangles. Those things you need to absolutely memorize. Otherwise known as the literal first side that I gave you on this reference sheet. This you actually need to memorize. You don't have to memorize the table per se, but you need to remember up until the important triangles. Okay? Okay. Other things you need to memorize. Okay. Other things you need to memorize is a couple identities, which it sounds to me like she's going to give you, because there isn't much else to give you by the looks of it in your textbook. Sine squared. Oh, I need to get rid of that button. Drive me nuts. Sine squared plus cos squared is equal to 1. You can manipulate this several different ways to get other identities. Like if we subtract sine squared from both sides, it could be cos squared is 1 minus sine squared. Or we could subtract cos squared from both sides, so cos squared is equal to, or sine, I should say this properly. Sine squared is 1 minus cos squared. These are just manipulations. Yes. Ironically, she might only give you this one, and you need to understand how to get other ones from it. You know what I mean? They're quick. They're easy to recognize. Other fundamental things you need to know. Tan is sine over cos. And then the reciprocal identities. I believe she's giving you the law of sines and law of cosines. So I don't think you have to worry too much about that. Like law of sines. Law of cosines. And how would I write? Yeah, all she said was identities. There is a multitude of identities, but you can also manipulate identities to get what you need. For example, remember how I said sine squared plus cos squared is 1? I can also turn that into 1 plus cotan squared is cosecant squared. Or 1 plus tan squared secant squared. So let me just quickly breeze through for assignment thing again. Chapter 5. Solve the triangles, use the trig. Not bad. Okay. That's about as far as you need to go for memorizing. I don't even really think you need to memorize this stuff too much. I'd memorize these two just in case. But on this other page is what you have to memorize the most. These, for sure. 2 triangles, for sure. Everything else, not so much. Okay. Okay, now let's test your reasoning skill. Wha-bam. The base of a 6-meter log rests against the ground. It ramps up to a branch in a tree at an angle of elevation of 26.2 degrees. Calculate the height of the branch to the nearest tenth of a meter. What is the distance from the base of the tree to the base of the log? Show me. You might as well give me that the link to that thing that we do, and we'll get you to draw the triangles for these so that I can make sure that you label them correctly. Okay. Doesn't look the same as what we did before. I'm just gonna scroll up a bit and see if it's in there. Did you figure it out yet? I'm still scrolling up to see if I can find the link. And looks better. Okay. Draw me the triangle. Draw me the triangle and label it for me. Well, you got this so far. Do you not have the question up front? Six-meter log with 26.2 degrees elevation. Yep. 6-meter log rests against the ground. It ramps up to a branch in a tree at an angle of 26.6. I don't know why I want to write 0. 26.6 degrees. Here's your tree. Here's your ground. So, tell me how to solve this question. So, do the A part. Calculate the height of the branch to the nearest tenth of a meter. How would you calculate the height? And remember, I go back and go to our page, but 2. You would be using one of these. You're not quite done yet. You only have sine of 26.1 degrees. You gotta finish writing it out. The answer is not just sine of 26.2 degrees. There you go. So instead of using a question mark though, use like a letter. So I would say T. So we would have sine 26.6 degrees is equal to, well, sine is opposite over hypotenuse. So T over 6 meters. Solve for T. calculator time. It's not going to be divided by. So you have a number that's divided by 6 here. Why would you all of a sudden just have a divide by 6 over here? So that's not how that would work. You would multiply both sides to get rid of the 6 meters, right? You multiply by 6 and multiply by 6. This 6 cancels out with this 6, so that t is by itself. So t equals 6 sine of 26.6. And it's 2 degrees. Why am I bad at writing these down? 26.2 degrees. Yeah, so all the regular algebra still always applies. That doesn't change. Hey, Buffs. Brains. We're doing some math, all right. We've got a nice little screening share little option here while we work on things. Okay, so type it into your calculator. What's 6 times sine of 26.2 degrees? Make sure your calculator is in degrees. All right, so sine of 26.2 times 6. 2.64, yep. That's what I got. So now the B part question. B part says, what is the distance from the base of the tree to the base of the log? So basically you're finding out this value here, your ground. We'll call it G. So find G. Okay. Next time we got to get the foods. What did you get anyways? Did you go have fun and have foods? I saw your little message about paying for drinks at the wedding. That seems a little absurd. Yeah, $7 is absurd. Usually it's $2. Yeah, exactly. So, G. Okay, bud. Why are you? A lot of bathroom drinks. Remember to use other trig functions as well. You You can think of that as well. Don't just be like G equals. Think of the other trig identities. You don't need sine because you already have the height. You're missing the G, the ground. There you go. Getting some cosine into this is much better. You went back to Lethbridge right away? Interesting. Yeah, that would be true. Not knowing anyone else there. They would go to Banff, wouldn't they? Well, of course it's cold now. Okay. So, the ground, you used cosine. Cosine of 26.2 degrees is going to be adjacent over hypotenuse. So that would be G over 6. So 6 times cosine, 26.2 degrees is G. You're not distracting, Bubs. We're doing work. We're all good. Yeah, Toronto's too far, bud. Way too far. You have to fly there. Yo, we make fun of people from Ontario. I don't know why. We just do. If we go further, like the Maritimes, then we just really have no idea what's going on. I have a couple people that I know moved to Toronto, and they seem to be enjoying it. One moved to Toronto because he just... That's all the opportunities are. Yeah, living in Iqaluit. Up north sounds very different. Okay, so we did this problem. One button. 6 cosine 26.2. 5.38. And that makes sense. But see, that's your problem right there. Buying Fanta. Who buys Fanta? Anyways. A square has a side length of 20 centimeters. If a diagonal drawn, what is the length of the diagonal? Give the exact value, not an approximate. That's an interesting drink. That would be very, very tough to withdraw. Anyways, draw for me how you would do question 2. Where is it there? A diagonal? You don't want to know what a diagonal line is? A diagonal line? This is considered a diagonal. The hypotenuse is considered a diagonal. It is a diagonal line going from one corner to the other corner. So if you draw a square, the diagonal go from one corner to the other. It goes through the center. The diagonal goes through the center. You go ahead and erase your page and then let's see it. It's a diagonal is like the hypotenuse of a triangle. It's from one corner to the other. Like there's a few things that I'm very questioning. It's like, why do you not know this? You just like choose to forget? No, that's the side length. A square has equal side lengths. What's a diagonal of a square? A diagonal going across. This is considered a diagonal line. So a square has 20 centimeter side lengths. And it says square, which means every side is 20 centimeters. Okay. So, you need to find the length of the diagonal. Okay? Well, just look and notice that this is just a simple triangle. This is 20 centimeters, and this is 20 centimeters. And this, we're missing. We're going to call this R. So, How do you find that last length? And I'm going to tell you one quick, easy word. Pythagoras. Nope, not 10. You need to find r. That's what it says in the question. You need to find the side length of the diagonal. What is the length of the diagonal? Give the exact value, not an approximation. So 20 squared plus 20 squared is r squared. Yes. Nope, no decimals, not allowed. That's not an exact value. Do not type into your calculator. It says definitely don't do the calculator. It says exact value, okay? In the question, it says exact value, not approximation. If I bring this up, right here it says give the exact value, okay? Exact values means no approximation. A decimal, when you do like the square root of 2, you'll get a bunch of decimals, right? Square root of 2 is 1.41421356 blah 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 blah. And you don't want to do that. That's not an this is an approximation. Okay? You do not want to do an approximation. You want the exact value. So you would write actually square root of 2. Did my mic just cut out? No, it's still there. Don't ask when would you use this. That's not relevant. You use this stuff all the time. It says in the question, bud. When the Pythagorean theorem, you would know automatically, what is the Pythagorean theorem? X squared plus y squared equals r squared. That's 3 side lengths, bud. Pythagorean theorem is 3 side lengths. No angles. Okay? So if I draw any triangle, it's a right triangle, but I don't give you what the degrees are, but I give you 2 side lengths, like 20 and 30, then you would use Pythagorean theorem to find r. Or if I give you I can't answer your question like right away, bud. You need to have like 2 side lengths. You know what I mean? Your question is a lot higher. I'm sticking to mostly the regular first year and high school. Okay, so let's move on to solving your question here. Well, let's see it. Like, we're kind of in the middle of doing his review for a while. Then, when we're done that, I can take a look at it. Or I'll do it on the side when he's working on something. And where are you in school? You got a weird, move this corner, I can see you. Okay, so next question. We said we've done this one, so now on question 3. Draw for me your triangle. Let's see your triangle. Yep. So you've started your ABC. Let's see your sides. So write down your I'm still talking to FTW. So right now, currently, he's given me a little drawing that he's working on, so I can see in the middle. But once he's done drawing, then I can move on and continue with the drawing as well. Okay. You drew a triangle like this. 5.4, 7.2, and 10. So the problem that you're having with this triangle you see, you're thinking it's just going to be straight Pythagorean. There's no right triangle here. Chapter 5 doesn't say anything about a right triangle. Yeah, see? You've got it. Drill, we're currently working on FTWs. a little bit of review here for his questions. So what's the law of cosines? Nice, nice. You got a study guide going on. Think about what the actual equation is. So first off, we have to just kind of label. So if you got this question here, we need A, B, C, and we need angle A. So angle A is this opposite of, so if this is little a, this would be angle A. I can't see your picture, Trill. It's cut off most of it. Can you just resend it? It somehow it condenses and crushes. So again, you need to rethink about the law of cosines. So rethink your law of cosines. We know what this is going to be. We have our A value. We have our B value. We have our C value in your law of cosines, right? So if we rewrite this, this would be what? A squared. This would be B squared plus C squared minus 2bc and then cosine of A. So when we are talking about this angle, you need to solve for this right here, bud. You didn't. So you wouldn't write A squared is equal to. You actually have to fill in. You have to solve for A. So you have to rearrange this whole equation and solve for this capital A. Do I have to mute you, or are you gonna let him be? We are currently working on FTW stuff. If you want to give them a hard time, then get out. I don't have time. What did you do to solve for it? FTW, you have to tell me how you're going to solve for it. Cos of 5.4, no. You have to solve for this big angle. We don't know what the big angle is. This one right here. We don't know what that is. That's what we need to solve for. Law of cosines. You have to plug things in and rearrange it. Nope. Nope. Stop. 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 What is A? You have the answer to A already. The lowercase a. You wrote it down. Why would you plug in A here and then plug in the rest of the numbers? You are solving for the big angle. Okay. Hey, Keela. No, no, no. Why would you plug in 5.4? We don't know what that is. This is what we don't know. Yes, cos A. There you go. Okay. Plugging in your values. A is 5.4. 5.4 squared. B, we've got a 7.2 squared. C, we've got a 10 squared. Minus 2 times 7.2 times 10 times the cosine of A. I would say don't bother writing or calculating things out yet. Just rearrange and solve for the cosine of A first. Are you seriously trolling right now, bud? For real? No, not you. Just leave. Resend. Okay, write down your question again. So you don't need to square things out right away. You should just rearrange and solve for first. So if you subtract, we've got 5.4 squared minus 7.2 squared minus 10 squared equals negative 2 times 7.2 times 10 times the cosine of a. Or you could go the other way and make it so that the minus signs are better. Either or, doesn't matter. So when I'm going to do this division, I'm going to flip all the signs. So we're going to have a 10 squared plus 7.2 squared minus 5.4 squared all over 7.2 times 10. And this is equal to the cosine of a. So you take the inverse. Cosine inverse of this mess. Cosine. Honestly, Rajan, I've seen lots of people have super huge study guides for some reason. I divided by it afterwards. You just are a little bit slower on that one. Hey Raj, thanks for the follow, bud. Seriously, bud? Didn't think of it. Number 4 is the one where we do W1 and W think. Let me look. Well, draw your diagram first. So I need you to draw your diagram for me. Let's see it. You've got hockey goal. Got a hockey goal. 2 meters apart. The player attempts to score by shooting the puck along the ice from point 12 meters from one post and 10.1 meters from the other. Within what angle must the shot be made? So I want you to rethink again. Think about it again. Posts of a hockey goal are 2 meters apart. Okay? A player attempts to score by shooting the puck along the ice from a point 12 meters from one post and 10.1 meters from the other. Within what angle must the shot be made? So kind of think about top down. This is all I have there, Keela. So, Raj, I'll go through yours in a quick second after I'm done with his drawing here. Because then you should be able to figure it out. 2 gold posts, 2 meters apart. He's shooting from one point, right? And if he misses, he goes outside these, right? Going outside this angle is a miss, right? So if he shoots the puck over here, this is a miss, right? If he shoots over here, it's a miss. Okay, pretty straightforward and understanding there, which means for him to score, it has to be within this little angle. Okay, so it said that he is 12 meters from one point, so let's say 12 from here, and 10.1 from here. Okay, this is the same thing again, where it was, we need to find this angle, call it angle A. So this is the same thing where you need to do your law of cosine. Okay, so again, this would be like your A, this would like be your C or B and C, and you need to find your angle A. Exact same setup as the previous one, bud. So you can do it. Hey, Raj, quadratic function vertex form. So the quadratic function has a form a of x minus, I'm going to say p squared plus q, or we'll use q. This would be like vertex graphing form. Law of cosines is the very bottom one, bud. We just did the law of cosines in the previous question. So then the vertex of this form is p comma q. I'll take a look. Rex is earned a list of 500 vocabulary words, and what's the number of words he remembers? I don't know. That $T weeks? So anyways, this is your vertex form with that vertex. For your question, this is like an exponential decay. A function has an exponential decay, so like y of x, for some constant e to the negative k x. So it looks to me, okay, FTW, what's your question? What? Do you mean how do you do? It's the same as the question we did before. FTW, it's literally the same question. It's just got different numbers. We are trying to find the angle, right? You have to resolve for the angle. This is the angle we need to solve for. He's still writing it down. No, FTW. Oh, okay. Apparently, I can't just let you do the exact same question. Okay. Khan Academy's good. If this is your angle, this would be your little a. So in the formula, we have this big X. So big X, little x. Okay? You did do law of cosines. It's there. It's in your textbook. X squared is equal to, I shouldn't say plus, y squared plus z squared minus 2yz. Cosine of x. This is your 2 meters. This is your 12 meters, or your 10.1. This is your 12 meters. This is 2. Minus 2 times 10.1 times 12 times cosine of x. So you need to solve for the x. Because it's the opposite of the angle we're solving for. This is x. This is the angle for x. Just like in the reference sheet. Okay, bud? The reference sheet has the triangle written right next to it. The angle for x and the side for x is the opposite one. Again, right here. The angle is what we're solving for. Okay, you do it. Okay. With your 500 vocabulary words, that's his initial learning. So his like y of 0 would be 500. He's remembering less and less words exponentially. Okay? And it's per week, so it's in weeks. If he remembers 450 words after 3 weeks, that means y of 3 is 450. How long does it take for the number of words to remember to decrease by 40%? How long until %? So 40% of his original amount. So with the first bit of information, we can solve for some variables here. When x is 0, this exponential function is just 1, because e to the power of 0 is 1. So then c is 500. Okay? Then when we've got an x is equal to 3, we know the value is going to be 450. So 450 is equal to 500 e to the negative k. And now it's when x is 3, so 3. Solve for k. Solving for k. Divide by 500. Do it on a new page. You got to remember there is a decimal point there, FTW. 10.1. You got to make sure you write down the question accurately. Okay, so we have 450 equal to 500 e to the negative 3k. Yeah, you still have to solve for the cosine of x. Solve for cosine of x first. So go for there. 450 divided by 500 is e to the negative 3k. Well, to get rid of this e, we take the natural log. So natural log 450 over 500 is equal to negative 3k. So then we divide by negative 3. So natural log of 450 over 500 over 3. Okay. Oh, Raj, good job. Well, you said you had such a huge one and you're already almost done. Okay, okay, this question is not done. FTW, I'll come back to yours in just a quick second. I'm just going to explain the last piece. So we know what K is here. We need to find some value, so y of x, when it's equal to 40% of the original. Okay? 40% of the original. So what's 40% of the original? Well, 500 was the original, so 40% of 500. Or you could say 0.4 of the initial value, and I'll say I. And remember that the initial value is what we would put at the front of the equation. So we have e to the negative k times x. Well, the initial values are canceled. So 0.4 is equal to e to the negative kx. We know what k is, so we can plug that in. Solve for x. Okay, FTW. I want you to solve first. Solve the equation for x first. You also forgot to divide for. Why did you add 240? So if I go to this equation, 2 squared equals, was it 12 squared plus 10.1 squared minus 2 times 12 times 10.1 times the cosine of the big angle. Let's call it A. You can bring over these ones, yeah. So 2 squared minus 12 squared minus 10.1 squared. Then it's still equal to the minus of 2 times 12 times 10.1 times cosine. That's where you're screwing up. I don't have time for this. Okay, FTW. Divide by this number right here. So the signs will change. So I'm going to just work that out right away. So 10.1 squared plus 12 squared minus 2 squared. Because I don't solve things first. I don't plug things into a calculator until the very end. Divide by 2 times 12 times 10.1 is equal to the cosine of A. Take the inverse, cosine inverse. But here's your equation right at the beginning. This first top line. We have to solve for cosine, get it by itself, right? Follow me there? Okay. So remember that this is acting on a multiplication. This is multiplied onto the cosine. So if I just rewrite like any little example, This is 3 plus 1 plus 4a, right? I didn't want to add these numbers up because it's too complicated right off the bat for me. I don't bother with that until the very end. But I need to still solve for this 4a, okay? So I would take these two to the other side and subtract them, right? Like 2 minus 3 minus 1 equals 4a. Okay, that's the same thing we did. We took those two numbers over to the other side and subtracted them. Okay, then we have to divide by what's multiplied onto our number. So this minus 2 times 12 times 10.1 is divided by, yeah, I just kept it in the powers. Now that it's fully solved, then you can start typing it in the calculator. There you go, bud. Come on, I just want to clear things. He's getting it. Except you're screwing up a sign already. You need to divide. You're messing up your signs, bud. What is... It's not going to be a positive. When you move this number over... Remember, this is a negative here. You're going to divide by it. When you move the 10 over, it's going to be negative. It's positive on this side, but when you take it over, you subtract. Just like you did with the 12 here. When you take the 12 over, it became negative. Why wouldn't this one do the same? There you go. He's getting there. He's getting there. Okay. He's got it! Now he can type it into his calculator. But he's still forgetting to write to 10.1. Okay. Let's see. You're probably not typing it in properly. Let's break it down, shall we? 10.1 squared plus 12 squared minus 4, 242. 24 times 10.1 is 242.4. Cosine inverse of this, 242.01 divided by 242.4 in degrees. Oops, I wrote 24 in my calculator. The buttons must be getting weak. 4 again, 242.01, 2.4, 3.25. Okay. While he's doing that, let's move on. See if I can draw this triangle or rectangular object. Okay. Not even going to assume. This is apparently a right triangle. This is 70 degrees. This is 65. This is 55. 115. 19 centimeters. This is a little x. E. E. D. And C. The question says, solve for the side of EB. Weird. Why did they put a little x if they want to solve for EB? I'm going to call EB Y. Okay, bud. Long bathroom break. Jeez. Probably got sidetracked. Yeah, good idea. I should probably open the window. It's getting warm in here. Okay. So this is the next question. We know a couple things. We could use lots of different ways to solve it. How would you like to approach it? There's no right triangle. So this isn't a right triangle. Neither is this. Neither is this. This inside angle apparently is. But no. So I'm going to ask you a regular question. What is... How many degrees is a straight line? No, not infinite. 360 degrees is all the way around. No, 90 degrees is a perpendicular line. Yeah, 180. 180 degrees is a straight line. Okay. He believes in you. What is the sum of all interior angles of a triangle? What, you want to do easier stuff? Let me see. Maybe you aren't ready for this question yet. Let me look at the other ones. Maybe they'll be a bit easier. Okay, you know what? Let's pause on this one. I want to see, based on what we've been doing, if you can do 7 and 8. At least one part of it you should be able to do no problem. I want to see if you can do 7 and 8 no problem. We'll pause on this and we'll come back to it. Okay? But show me that you can. 7. If you can do it, you can do it right away. Yep. Let's see what you got. Okay, well, that's a start. You wouldn't write it as like 4 over -9. You just write the negative on top regardless, because it's the same thing. What about the other stuff? You kind of have to find the other values. So you're missing a value. You were given a crucial piece of information, though. Not necessarily. There is a reason why I'm highlighting this. What quadrant is 270 to 360? This is 90 degrees. This is 180. This is 270. This is 360. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So what quadrant is 270 to 360? Fourth quadrant. So in the fourth quadrant, we're over here. In the fourth quadrant, is x positive or is x negative? Remember, this is the x-axis and this is the y-axis. So you should be able to tell me which is positive and which is negative. Remember, here is 0, so go. The reason why I'm asking you this is because you said you know how to do it. So I'm asking you if you know how to do it. Where, tell me, is x positive or negative in this quadrant? Quadrant 4. No, x is positive. This is to the right. X is positive. Is y positive or negative in quadrant 4? This is exactly like a graph. This is a graph. Yes, this would be y is negative. Now you did say the proper terms before, but I needed to make sure you understand that it's the quadrant that makes the difference. Because, just because it's a -9, if it was in this quadrant, like quadrant 2, then y is positive. So it's not going to be a -9. I don't want you to screw that up. You know what I mean? Okay. So now we've got y you said is negative, minus 9. Because 10 is y over x. Y is minus 9. X we know is positive, so x equals 4. We're still missing one number, missing r. How do we find r? Gonna be the same like we did before. Pythagorean theorem. Right triangle. Bubs knows. Yeah. The bot didn't like it. So what is r then? Don't use a calculator. Gotta tell you every time. No calculamators. Only use a calculator when you're doing something different. 4 squared is 16. 9 squared is what? 81? Need the square root of that to give us r. What's 16 plus 81? Good. Square root of 97. Does 97 break down? What are the factors of 97? I think 97 was prime. One of those higher ones. Remember. Yep, 97 is prime. So, r is the square root of 97. And you can't do anything else with it. That's just what it is. Now, you have to fill out the rest. Nope. No rounding, no decimal numbers. You leave it as the square root of 97. That's it. This is considered the exact value. Just that 97 is a prime number. Just like how we would be left with the square root of 2 as a number. That's a number. Just the square root of 2. Square root of 97, that's it. Now you gotta finish solving the rest of your trig ratios. Okay, so what's cosine? I'm just going to write down all the values again so that it's all on one page. Y equals -9, x equals 4, r is square root of 97. Okay, cosine, x over r, 4 over square root of 97. Remember, you have to rationalize. So what does this rationalize? Four root 97. 97. You just forgot the 4. Okay, what's the next angles? Or the next trig ratios? You can't? Yep. Square root of 97 over 4? Nope, it's already rationalized. You only need to rationalize when there's a radical on the bottom in the denominator. The radical is this root sign. Whether it's a square root or cubed root or fifth root or 1080th root, you know, it's just that the radical sign. Okay, so what are the other trig ratios? You've got tan, you've got cotan, cosine, and secant. You're missing sine. Yep. Sine. -9 over square root of 97. Gotta rationalize. So -9 square root of 97 over the 97. You got one trig ratio left. Cosecant. So again, you don't need to write the minus on the bottom because it doesn't affect anything. Still write it on the top. Square root 97 over 9. The last part, B, to this question was determine theta. What's theta? I was about to type theta. Theta. And remember, you had a simple one. Tan theta is equal to -9 over 4. Theta is going to be the same for all of them. You can use any of them. They'll all give you theta. Theta is one angle. You've just got all the trig ratios for that one angle. You could even use sine or cosine. No, you just take the inverse. How do you remember that inverse button? Inverse of both sides? Theta equals tan inverse. -9/4. Seriously? Go to YouTube, bud. Just go to YouTube. You seem to have this issue. Yep, Bubs. Definitely. Okay, you're on YouTube. The only thing is I don't think YouTube chat box comes up. Yeah, yeah. You got timed out. Okay. Yeah, Bubs, he was being bad, you know. Kids these days can't figure out how to use, you know, regular language. Yeah, exactly. Watch your mouths. No, FTW, you can use little notes anytime you want. The whole reason you get scrap paper and space on a paper on your test is to write things. Now, if you're referring to like cheating, then I'm gonna say no, it's not worth it. No, no cheating. Every time somebody asks me about cheating and stuff like that, instant, nope, don't care, do whatever you want. I am not giving you any help. So, no cheating. Not gonna happen. Don't help with cheating. Yeah, I know you're joking. Okay, so you know how to find the inverse. What's theta? You just type it in your calculator. This is something you can type in your calculator. Yeah, so you got negative 66.03. Or I believe the question says round to the nearest degree, so 66. Theta is negative 66. But we can't write it as negative 66 because it's not between 270 and 360. So we need to write negative 66 degrees. So this is like negative 66. We need to write it as a full angle between 270. Yeah. Subtract it from 360. So this is 360. The whole range is 360. We just need this big portion, so we subtract the 66. Yep, 294. Okay. Next one. Question 8. I'm going to write down question 8, and I want you to start doing it for me while I take a quick pause. Okay. You lurk, Bubs. Are you streaming tonight there, Bubs? Or are you busy? Yeah, okay. Are you gonna do the new event in Oberbloch? Your new emotes? No, FTW, I have no kids. I'm still single. Hoorah. Yep. Still single. Okay, I'll see them, Bubs. Let's see those emotes. Of course I cook. I've always cooked. I'm single because the last relationship I had didn't work. Besides, I mean, you can never you can't even be married on stream because that's just bad, right? You can't have other people. Yeah, we'll find her one day. Around the corner, left or right. I don't know if she'll be a Saskatchewan girl. My previous relationships have all been really people that are not from here. For example, China, the Philippines. A lot of Saskatchewan girls don't like me because I don't listen to country, like at all. And there's this thing about Saskatchewan girls that like country for some reason. Snow bunnies. BC girl or Albertan girl? Okay. Ironically, my sister Crystal and her kids live in Calgary, and my other sister Jen lives in Vancouver. So I kind of only go that direction. You guys get more snow than us. Saskatchewan hasn't gotten very good snow lately. Okay, what, pups? What? Let's hear it. Okay, I can meet an Albertan girl and then move. But why would I want to move to VC? Okay, FTW. This is the next question. You need to solve it. Go the right hand side. True. Not Sask is nice too. It's a serious question. Let's see this. I don't know. What do Saskatchewan people call themselves? We don't say Saskatchewanians or anything. We just say we're from Sask. I know. Alberta people call Albertans. Oh, those Albertans. Oh, those Ontario people, or those Torontonians, or we just say we're from Sask. Yep. But Bubs, serious question. Actually, Bubs, look up shit Saskatchewanians say. There's this YouTube video that friends of mine did years ago that blew up and was pretty popular. Shit Saskatchewanians say. If you've seen that video before, oh, I think that's the one. Biz Trapdoor. I think that's what they called themselves when they did it. Yep, that's the one. These are buddies of mine from high school. Serious question though, Bubs. Bubs, what is this called? What is this called? Bubs, what's it called? Hmm? What is it called? This nice little, you know, sweater-ish. It's called a bunny hug. In Saskatchewan, it's a bunny hug. The only place ever. Yeah, it's a bunny hug here. That's what people call it. You know, there's bunnies running down the road. There was one earlier today. It's a bunny hug. You know, we like to hug our bunnies. God, I hope FTW comes back quick. What do you mean nobody hugs bunnies? You don't like them? They're really soft. I used to have a bunny. They only bite you. I never got bitted. Alright, FTW. I gotta find out what this is I'm listening to. The World Alive, eh? Do I like The World Alive? Not bad. A bunny ate your friend's jacket? Okay, FTW. -10, summer's come early. Yep, that's us. So true. Yep. I mean, everything in Alberta is pretty much the same as Saskatchewan. What do you want to ask, FTW? Valuation? Yeah, you probably watch more hockey because you actually have hockey teams. We don't have hockey teams here. Just the Rough Riders. Just, just. Yes, the Rough Riders. You mean believe in evolution? Do you? You can't believe in evolution. Evolution is just a fact. Okay, sign. Do this right side. Get a pill. Again, FTW. Evolution does not mean religion. You can't confuse those two. What about the eyebrow or bigger? There's weird towns in Saskatchewan. You actually have to look it up. You should also look up the town bigger and the sign in bigger. Okay, FTW. Show the right-hand side is equal to the left-hand side. Grandpa died shoveling last night. Okay. Well, you made it back. Just try not to swear so you get timed out again. What? Factor using X. No, what's... So we're gonna use the right-hand side. Can you delete your stuff? Just clear your whole layer. There's a little button over top the layers. It's a little eraser button. It just clears the whole layer. Or erase it, that works. Nope. Yep. So you're going to just mess with the right-hand side. Don't bother with the left-hand side. Just only the right-hand side. Well, you're doing it right so far. Except for you forgot to write the 2 on the co-squared. Remember, you gotta know the identities. We were talking about the identities at the beginning. Sine squared plus cos squared is? Because this is cos squared. You took out a sine x. You didn't take out a cos x. Remember, when you multiply things back in, you have to get back what you had originally. This is all there is. Nothing's changed. What do you mean how? If you had like 8 plus 2x and you took out a 2, just a 2, you would have 4 plus x, right? If you multiply that back in, you get back your original, 8 plus 2x. You took out a sine. No, you only took out a sine, which means this is still cos squared, because this is cos squared. You didn't do anything with the cosine, so it would stay the same. Yeah, you only brought out the sine x. You didn't do anything extra. Nothing special, just factoring one simple term out. Because you took out a sine. If you have x cubed and you took out an x, this would still be x squared, right? Okay, now continue. Good. Sine x over cos squared x, because this is equal to 1. So then just keep going. Remember, you need to turn it into tan and secant. Okay, you keep going. Yeah. Sin x over cos x times 1 over cos x. That'll give you your tan times your secant. Okay, I'll be right back. I have to go check on dinner. I'm just gonna write a BRB. FTW. Sin x over cos x times 1 over cos x. Same thing. Just like you wrote there. There you go. You got it. Bubs is lurking. Okay. No, I didn't cross out the cosine. All I did was break them up. Just like you did. See if I can eat without making a mess. It's getting warm. Split them up. So it goes to multiplication of the split. Might as well see if I can write some stuff down before you get back. 7. Where am I? Okay. I was going to did the chain rule, power rule? Yep, power rule. Okay. Where am my text? Going to blue text. 12. The power rule, yes. Let's see. Put this over here a bit, and then I'll move the other one. More lined up. Quotient. There, that looks a bit better. Do, 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 do. Well, bam. Financial formulas, Rift? Oh, I have to W back. I haven't done my finance stuff in a while. Yeah, you don't live in the White House, FTW. You live in Toronto. Oh yeah, yeah. Present value and bond value stuff. I don't remember like all the formulas off the top of my head, but definitely have done them for sure. Yeah, I know. You do need basic math skills for business, but they don't extend much past understanding of lines and maybe a few formulas. Unless you go into like real financial stuff. But if you're going into like maybe management or marketing or something, yeah, you don't need as much math as you may think. if you went into like the huge design portion of marketing where you were maybe like designing with mathematical formulas, that's a different thing. Do you consider actuary as business? I don't really consider actuary as business. FTW is not going to do actuary though. An actuary is basically the people that do all the calculations in mathematics and statistics for like insurance, evaluating risk. So like the premiums for like the car insurance or life insurance and all that stuff, that's made by actuary. I was looking at becoming an actuary. In fact, I talked to two actuaries who were the head of Scotiabank. And it turns out there's only two actuaries in Scotiabank. Hmm. 40%? I think it's a lower percentage than that. So I think there was like the Society of Actuaries has at least 6 tests. The first test alone has only like a 40% pass rate. Yep. Roblox, it's Roblox. See, guys, this is what students are supposed to be like. When people come into the stream, like Rift here is a good guy. The person that was here earlier, the whole reason why we had to ban him. Mm-hmm. Okay, be right back. Okay, yeah. You're gonna go now too? Okay, you go eat. I'm kind of getting a little bit tired here. Got some other things to go. Let's see what we have left, shall we? Question 9. Yeah, you were saying you got KFC. Yeah, it's quite late there. Hey man, 9 is late for most people. That's like the, okay, time to shut it down. Okay. But you've got one legitimate question left. And I'm kind of done. Just go grab your food. Go have your food. I can work on the other page for a little bit. Or Rifter and here can talk for a bit. No, when I'm done tonight, I gotta be done. I'll be required elsewhere after. Yep, you go eat. Oh, okay. Let's finish these derivatives. Hey, Riff, do you need these pages? You're in uni. It does. I don't think you do. You might. I made these a whole bunch of reference pages. Yeah, you're probably gone. Okay, don't need that. Okay. Okay, well, I'm gonna have to finish this up then. What was I gonna do after the power rule? Trig? Because I did trig. If I do a trig again, it would be consistent. Yep, I did trig and then logs. Yeah. Uh, trig functions. Okay, time to do all of them. Okay, trig. Derivative of sine, then cos. Oh no, why is it having issues? Why did it do that? Please tell me why. Having troubles with duplications now. Maybe we'll just make a new one. Okay. Derivative of sine is cos. Do I want to change it to make more sense, or just leave it as X? Nah, we'll just leave it as X. Oops. Okay, derivative of cosine minus sine. Derivative of cosine is minus sine. 10. Derivative of 10. Int squared. And again. Not bad. Cosecant. Derivative of cosecant. And x. Cotan x. Secant. Secant x 10x. And derivative of cotan. Cos and squared. It doesn't look bad. Holy cow, is it warm? I need a fan. Hope FTW comes back soon. I got places to be. Or maybe. We're gonna try something. We're gonna try something. I like the sounds of trying something. To save this. Okay. Push. Let's see how this works. Okay. The question is we've got the angle. Theta lies in quadrant 2. So no calculator. Determine which of these are true. Got A is cosine of theta is equal to negative 1.001. B tan theta is equal to negative 1.323. C cosecant, get that better. Cosecant theta equal to negative 0.542. And D cotan theta is equal to 0.747. Okay. I think what I'm going to do is I'm going to just record a quick video and see if I can post it real easily. That way I could be gone. It might work better. Think I can do it in time? No idea. So let's just quickly go through our reasoning. Well, cosine theta is x over r. R is the longest side, which means, yeah, this doesn't quite work. Can't be bigger than 1. Tan theta can be, but cosecant. Cosecant theta is 1 over sine theta. Again, cosecant theta would be like r over y. R is the longest side, which means this should be greater than 1. That doesn't work. Cotan, y over x, x over y. That's fine. The only thing is it's in quadrant 2, so it has to have a negative. The only other one to think about would be tan theta. Tan theta would be y over x, If it's in quadrant 2, x would be negative and y would be positive. So sure, that could work. Now let's see, how would I write that out real quick and easy? Do really need that fan though. Holy cow. Wait, I can just explain it. You can go to the VOD. What am I thinking here? Okay. Simple enough. Cosine, well, easy to begin with. Quadrant 2. Quadrant 1, Quadrant 2, Quadrant 3, and Quadrant 4. If it lies in Quadrant 2, that means it's over here. Which means that y is positive and x is negative. Okay, a good start. Cosine. Cosine of theta with a ratio is x over r. Okay, again, we know this from our sheet. Cosine is x over r. R is the longest side. Okay, r is the longest side. Which means that if we have a number that r is bigger than x, that means x over r is going to be less than 1. Okay, so if we have a number that's not even a matter about the negative sign, 1.001 is greater than 1. So cosine theta can't work. Of this one, it doesn't work. The ratio has to be less than 1. I should say absolute value of the ratio? Yeah, absolute value of the ratio. Okay, second one. Tan theta. Tan theta is going to be y over x. So y could be bigger than x, or x could be bigger than y. It doesn't matter. So we're okay with the number being bigger than 1. The only thing that we would question then is the sign. Well, since it's y over x, we're in quadrant 2. One of them is positive and one is negative, so we can have a negative value. So b works. Equals negative 1.323. This works. We can have x bigger than y or y bigger than x. Since tan theta is y over x, that means we can have, I want to say quadrant 2. Theta is in quadrant 2. Tan theta equals y over negative x. So negative 1.323 is logical. Okay. Next one. Cosecant. Cosecant theta. Cosecant theta is 1 over sine theta. Okay. Well, let's even just stick with the ratio. Cosecant theta. Cosecant theta, again, using our regular ratios, is r over y. Okay. R is the longest side. So r over y is going to be bigger than 1. I'll write this a bit better, actually. R over y is bigger than 1. Since r over y is bigger than 1, and the value we're given is less than 1, is negative 0.542, is less than 1, doesn't work. The last one, cotan. Same reasoning. Cotan is 0.747. Doesn't matter if it's bigger or greater than 1. We only need to look at signs. Theta is in quadrant 2. So, what is it? X over y should be negative. You're back just in time. I was literally about to just be kind of done and kind of send you. But you like KFC, that's good. So I can just kind of explain this over again. So are you ready to understand 9? Because we've done it before in a previous, in your like homework in chapter 5. Okay. So the question wants you to determine if they're true without using a calculator. So you need to use your reasoning. I already wrote it down and went through it, but I'll go through it with you again. Okay. We're going to do A first. Cos theta is equal to negative 1.001. First thing we know is that it lies in quadrant 2. So quadrant 2 is this one over here. Yeah. Cos theta is not bigger than 1, so it doesn't work. Automatically, you got it. Okay, let's look at tan. You just have to look through the reasoning. Tan theta. Tan theta is, like, if you look at your reference page, okay, tan theta is y over x, right? I know, but like you're supposed to remember these already. I don't expect you to remember it at this exact moment, but you need to remember them, right? From the very beginning. We looked and said that theta was in quadrant 2. Okay? If theta is in quadrant 2, that means y is positive and x is negative. Okay? The range of tan doesn't matter what size they are, so that's fine. So the 1.323, that's a logical number for tan. All we need to worry about is the sign. We know that y is positive, x is negative, so a negative ratio makes sense. So tan theta works. So we know that quadrant 2, y is positive and x is negative. You following me there? Okay. Which means when we have the ratio y over x, we have a negative ratio. Since we know the value works and that the sign is correct, tan theta works. I just told you how. We know that the value works because tan theta is y over x. Y could be bigger than x, or x could be bigger than y. It doesn't matter. So the value for tan theta, as long as it's bigger than 0, will work. Since we know that the quadrant is quadrant 2, one of the signs is negative, so the division of the two will give us a negative sign. So this works. Yep, tan can be negative. Tan is negative in quadrant 2 and quadrant 4. So the B one works. So now we gotta look at the next one, the C one. Cosecant. So let's look at the value first for cosecant. What's the ratio for cosecant? No, not the range, the ratio. Like y, x, r, what's the ratio? R over y. Good. Okay. R is the longest side, right? The hypotenuse is always the longest side of a triangle. Okay? That means if it's divided by either of the other sides, it's going to be bigger than 1. So if they give us a value that's less than 1, it doesn't work. R over y is bigger than 1. They gave us 0.542. That's less than 1. Doesn't work. See how that works? What do you mean? The graph... This graph right here? You, it told you what quadrant it is. Okay? Theta is in quadrant 2. Okay? Where is quadrant 2? This one is quadrant 2. Quadrant 2 tells us where y is positive and x is negative. Okay. Last one. Cotan. Cotan of 0.747. Well, here's the thing. Yeah, so the things you can check are, does it make sense that it's positive or negative? And does the value itself make sense? Those are really only the two things you need to check. Well, okay. Remember, we found tan already. We know tan has to be negative because it's in quadrant 2. I don't even have to look at the value for cotan. Cotan is 1 over 10. In the second one, we already went through the logic. But the ratios are wrong. There's no negative defeats positive. None like that. That doesn't make any sense. We just went through that. We are testing to see if the numbers they gave us make sense. Okay? Can it be true? Like, we are testing, is it true that these ratios are possible? Given that we know theta is in quadrant 2. For the first one, you said immediately, no, it's not possible because it's not between -1 and 1. Perfect. For the second one, we found out that it does, in fact, hold true because tan theta is negative in quadrant 2 because y is positive and x is negative. So that would make tan negative. And tan can have a value like 1.323. So that worked. Cosecant, we found out that the value itself has to be bigger than 1 for it to make sense, regardless of the sign. It's not confusing. You're going crazy, man. I'm not even plugging in any values. There's no values. I'm just testing to see if they're logical. Like, I'm going to tell you, I've gone through that 3 times already. Come on, bud, pay attention. First one, cos theta. Why was cos theta not possible? Tell me that. Exactly. Done. Nothing else. Okay? Tan theta. Why is this one possible? Discord. Don't look at that. That's not the point. Don't look at that. Ratios only. Ratios only. Y, X, and R. That's all we've been going through. On the first page. That was the very first thing we were supposed to memorize, remember? Literally the very first thing we talked about today. These. You're putting them in. You're putting in the negatives, okay? That's exactly where they are. Right here. Quadrant. If y is positive, y is positive. If x is negative, put in negative x. You know what I mean? You don't have to put anything else in. There's nothing like, nothing special. You're not plugging anything else in. It's literally just be like, oh, x is negative. No, y is positive. Okay, go back. Why are you having troubles with this? I don't understand. Okay, I have a angle in quadrant 2. Over here. Okay, this quadrant has a positive y value, and x is negative. Okay, because this is to the left of 0. Are you good there? Okay. If I say tan theta is a ratio, okay, the ratio will be the y over the x, right? Y over x. However, where we are says that x is negative. So this is going to be a negative x. See what I mean? If I said we're in quadrant 3, yeah, if they don't fit with the ratios according to the quadrant, then they don't work. There you go. You got it. It's like me asking you, is 3 less than 1? And you say, no. You are testing it. Okay, going back to our testing. No, tan. We just went through this. The truth is, we're going to take like the regular y value. No, just the idea of the ratio, okay? The idea of the ratio is that it's going to be y over x. Whatever y is and whatever x is. Okay? So the actual ratio says that in quadrant 2, tan will be negative because tan is y over x. X is negative in quadrant 2, so it's going to be a negative ratio. If we are in quadrant 3, they're both negative. In quadrant 3, tan. Yes, all we're doing is testing the outcomes. We're testing to see if the number is logical. In quadrant 3, tan theta would be like negative y over negative x, because they're both negative. Well, a negative times a negative is a positive, so that's going to be just a positive. Okay. Quadrant 2. Focus on that. Okay, quadrant 2. We're going to do cosecant next. No. We're just going to test the logic. Okay. We're just testing the logic of each one, okay? We don't need to plug in any values. We don't need to solve for any values. We're just testing. Okay? Just like, is it logical? Like, I'm going to ask you, is 1/2 greater than 1? You're going to say, no, that is incorrect. That's a test, okay? Okay. Cosecant. Let's look at cosecant. Forget the sign for now. Let's just look at the value first. Okay? Cosecant. Logically, cosecant is what ratio? Good. R over y. R is the hypotenuse of a triangle. Okay? Which means R is the longest side. Okay? That means y and x are both smaller than r. Okay? No matter what they are always smaller than r for a real triangle. Okay? Make sense? That means when you divide the two, you're going to get a number that is bigger than 1. Okay? Don't worry about the sign. Start with just the ratio of the numbers. Okay? Like, r could be 2 and y could be 1. 2 divided by 1 is still big. Right? Are we good with this idea right here? The value they gave us was 0.5 something. They gave us a number that's less than 1. So it doesn't work. I didn't need to, because we already found out that the value doesn't work. There's two things we're testing. The value and the sign. If the first one fails, we don't even need to do the second one. Okay, the last one. Cotan. Cotan of 0.747. Automatically, we can do one of the two tests. I'm going to say the quadrant first. This time instead of the value. Tell me, does cotan have a positive or a negative value in quadrant 2? It's negative. Good. Which means this doesn't work. Because it's positive. You see how the logic works there? Theta is in quadrant 4. Does tan of negative 1.3 work? Does secant of 5.4 work? And does cosecant of negative 3 work? Okay, but after this, I gotta go. Like, I'm kind of way behind. Yep. Tan can work. Quadrant 4. So why does secant not work? Yeah, quadrant 4. Why doesn't tan work in quadrant 4? Tan's negative in quadrant 4. Why is negative? X positive. What is cosecant? What's the ratio for cosecant? Okay. Cosecant is r over y. R is the longest side. So 3 works. In quadrant 4, y is negative. So this works. Okay, bud. Both of them, they need to work together simultaneously. So you're testing if they're going to work logically with the number. What would I consider R? R is the longest side of the triangle. R doesn't have a negative sign ever. It's always positive. R is always the largest side. That's it. Yeah. To find out if the sign's positive or negative. You're welcome, bud. I'm gonna save these over and send them to you. You gotta memorize this first page, though. The very first page with the sine and cos, all this stuff. This is what you gotta memorize. For sure. Okay. Unless she's giving you these, which I doubt. Thanks for the $3, bud. Hey. It makes a difference. It makes a difference, bud. Thanks. Well, thanks anyways, bud. I mean, one day more people will just be around, I'm sure. People that don't give us a hard time for helping people out, though. I think I have to find a way to make like a semi-private chat so that when I help people, I can have just the semi-private chat, and then the other one can be the open one for everyone else. I don't think you need this one. Nope, you don't need this one. Don't need this one either. No, the other two I was other people. I believe it. Yeah, you said so. Yeah, chapter 6. It's okay. I don't think chapter 6 was that difficult to do. Bye, bud. All right. All saved up. Time to send them and be on our way. Let's try. Hmm. All right, well, that's all she wrote.